Today's lesson is on properties of logarithms, and our objective is going to be to simplify and evaluate expressions using properties of logs, and then to solve logarithmic equations using properties of logarithms. So first of all, we're going to review some properties of exponents that we studied earlier this year. Remembering that a logarithm is truly an exponent, truly a power, these properties are going to be related. So if you remember, the first property was the product of exponents. So if you're multiplying two numbers that have the same base, so here the base is b, if you're multiplying them, you're going to keep the base and add the two powers. So for an example, if you have, let's say, 2 cubed times 2 to the 7th power, you keep the base, it'd be 2 to the 10th power. All right, the next one is the quotient property. So here we're dividing two numbers that have the same base. We're going to keep the base, and we're going to subtract those exponents. An example of this would be if I had, let's say, 2 to the 8th power divided by 2 to the 3rd power. I'd keep that base, I'd subtract the powers. Last one here is power of another power. So if you have power of power, we're going to multiply those exponents. So if you had something like 2 to the 3rd and then raising that to the 4th power, that would be equal to 2 to the 12th. Some other fairly obvious properties of exponents that we've worked with, let's say 4 to the 0 power. Anything to the 0 power, remember, is equal to 1. Anything to the 0 power is equal to 1. Anything to the 1st power is itself. Anything to the 1st power is itself. A negative exponent, remember if the power was negative, we could take the reciprocal of the base to the positive exponent. And then simplifying this would be 1 cubed, which is 1, 2 cubed on the bottom, which is 8. So like we've talked about, you could ignore that exponent being negative. Just take 2 to the 3rd, which is 8. Flip your answer to get 1/8. All right, so then, moving into properties of logarithms. So the first property here is that if you are adding two logs that have the same base, so that's what we're doing right here. We're adding two logs that have the same base. What you can do is combine them and multiply. So just like when we multiplied bases with the same bases, we kept the base and added the powers. When we're adding the logs, when we're adding the exponents, the logs, we can combine and multiply. So for example, I could say if I've got log base 2 of 4 plus the log base 2 of 8, this could be combined into the log base 2 of 32. Combine them and multiply. In the second example, here we're subtracting two logs that have the same base. We're going to keep that base, and then we're going to divide those. So the same thing when you are dividing two numbers with the same base, you keep the base and you subtract the exponents. So if you're subtracting logs, which is like subtracting exponents, you can combine and divide. So for example, let's say we've got log base 5 of 20 minus the log base 5 of 4. This would equal log base 5 of 20 divided by 4, which is 5. The next one that we'll use quite often here is if you have a logarithm to a power. So here we have the log base b of m to the k power. Okay, so this is kind of like a power, an exponent of a power. What do? We multiply. So this power, this exponent, can be moved in front, and we can set equal to k times log base b of m. So an example of this is if I've got log, let's say, base 3 of 2 to the 5th power. That would be the same as, again, I can move this power out in front here. It'd mean the same as 5 times log base 3 of 2. Those are the three main properties of logs. Just a quick summary. If you're adding two logs with the same base, combine and multiply. If you're subtracting two logs with the same base, combine and divide. If you have a log to a power, move that power out in front and multiply. Other similar properties of logs, the ones that we talked about before, if you have the log base anything of 1, that will always equal 0. So log base 5 of 1, log base 8 of 1 is always 0, because anything to the 0 power is 1. Also, if you're taking the log base 3 of 3, that would equal 1, because 3 to the first power is 1.